All right, we are in Chapter 4, Section 2. This is writing equations in slope-intercept form. Yep, just form. Sorry, cut off the word there. So there's a couple of things that you will not see on my screen, but you will see on yours. The first thing when you log in your homework is you will see a due date. Teacher Preview just doesn't give me a due date for mine. The second thing that we will all see here is the attempts. So I'm on attempt number 1 of unlimited attempts. That means I can submit this assignment as many times as I would like. It doesn't take away any of the questions I've answered correctly. It doesn't make me start over or anything like that. I can just keep submitting this assignment over and over again, and we'll go over the submit button in just a moment. This assignment has 7 questions on it, so you'll have anywhere from 1 to 10 questions. 10 is the maximum per section. Grading policy is always best score, meaning whichever attempt is the best one is the one you keep. And partial credit is always enabled, which means that if you answer 1 of 7 questions, you get credit for the 1 question. And so down here this says, once you start the homework, you must finish it before you can work on anything else. And what that means is if I click start, and this is where the submit button is, I don't see this again on my screen, but you will see it down here in your bottom right corner, submit assignment. So as soon as you want to leave this screen, even if you've only answered 1 question, click the submit assignment button. Otherwise, the program will lock you out of every other assignment and won't let you work on anything else until you come back in and you submit this assignment. It also won't calculate in your grade. Your teacher can't see what you've been working on. It does all kinds of things if you don't click submit. So don't just close the screen. Make sure you submit the assignment. You will all also see these 3 tools on the side here. So explanation literally will explain this problem to you. So you're going to lose your question attempt on it because it's going to give you the answer. So it's not going to give you the answer and then come let you check the box. So it'll give you a little red X and you'll have to come in on another attempt to get points for that one. Example will show you a problem just like this one, and it'll just walk you through what it wants you to do. So here is a different problem, same idea. We have a table, we have yes or no. So as we go through, what it wants us to do is that first point is 1, -3 in the example, and it wants us to plug in 1 is for x, -3 is for y. It always goes x, y in our coordinates. So instead of x, I'm going to put in 1. Instead of y, I'm going to put in -3. And I'm going to see when I do this multiplication on the left, does it work out to give me -1 like it does on the right? I want to test, is it in fact equal? If it is, then check, yay, that's a solution, and I put yes. And then I do the same thing for the next one, and I have to do this for all 4 pieces. So I have to test all 4 points. And basically, we're just trying to test, is this a point on the line of this equation? As long as it's true when we get to the bottom here, then yay, it's on the line. If it's not true, like we can see number 3 here, 26 does not equal -1, that's false, so that's a no. That point is not on the line. So we're just going to go through and we're going to test that out. And once we're good with the explanation, we can close this. You can click on explanation, or example, sorry. You can click on example again, and it'll give you a new example if you want to look at another one. Message Center will quite literally send a message to your teacher, and it will attach a copy of the question you're looking at, so we know exactly where to come help you. All right, let me minimize this just a little bit so I have a little bit more room on my whiteboard here. All right, so if we're looking at this, we say for each ordered pair, determine whether it's a solution. So we have 4x minus 7y equals 19. So the first point they want us to test, remember it's always x then y, is -4, -5. So I have -4 and I have -5. The rest of this is all going to stay the same. And I'm putting parentheses around these to show multiplication. That's what the parentheses are for. So we have 4 times -4, that's -16. -7 times -5, that's positive 35. 2 negatives multiplied together gives you a positive. And then equals 19 just comes down. So remember, we're kind of questioning this equal. Does it equal? So now, if we do this subtraction here, and you can do 35 minus 16 instead of 16 minus 35. Sometimes that's a little bit easier. So let's see. We would get 10. I think that is 19, in fact, actually. So I think this guy does, in fact, work out correctly. I'm just testing it real quick just to make sure I didn't do that wrong in my head. Nope, we're good. So 19 equals 19. So check. That guy is a solution. So I come over here and I put yes. All right, so we're going to do this again. So now I have 3 and -1. That's my next point that I have to test. So I'm going to go 4 times 3 minus 7 times -1 equals 19. So the 4 minus 7 equals 19. You notice how that came down. The only thing that's changing is x and y. So now I get 4 times 3. That's 12. -7 times -1. Multiplying two negatives, so it's positive. And then 7 equals 19. All right, well, 12 plus 7, that is 19 again. So 19 equals 19. So we have another yes. And all of them can be yes, all of them can be no. You need to test each and every one. But usually it's a couple of each. It's usually not all, but I have seen it all the same. I have actually seen that happen. All right, I'm going to back up to the top here so I have a little bit more room. All right, so we're going to have -6 this time for x and 2 for y. And 4 minus 7 times 2 equals 19. Okay, so I filled it in. So 4 times -6 is -24. -7 times 2, that's -14. And if I think about this one, if I'm going on a number line, because sometimes this confuses students when you have two negatives, I have 0. This is my positive direction to the right, and this is my negative direction to the left. So if I have -24, that means I'm already going left. That's -24. -14, I'm also going left. So what it means, two arrows, they're going in the same direction. I'm going to add these and keep the negative sign. So I have 8 and 3. -38 equals 19. Well, no it doesn't. That's not true. So false, big X, however you want to mark that. And then we're just going to come over here and click no. Alright, let's look at the next one here. We have 9 and 6. So that's 4 times 9 minus 7 times 6 equals 19. Alright, so then we have 4 times 9, which is 36, minus 7 times 6. They're opposites, so that's why it stays minus. 42 equals 19. So that's definitely not 19. And we can even use this guy again here. I'll use a different color just so that you can see it's different. So with this one I have 36. Well, that's positive 36. So I'd be going in that direction. And negative 42, that'd be going toward the negative. So they're in opposite directions, so I know I subtract them. And then the bigger number tells me the sign. There's more negatives than positives. So this is going to be -6 equals 19. Well, that's not true again, so we're going to do an X there. Alright, so let's go ahead and check this guy. Yay! Okay, let's erase this. Look at the next piece here. Alright, so we have a table of values of a linear function is shown below. Find the slope and the y-intercept of the function's graph, and then find the equation for the function. So the slope, that's rise over run. So we need to know what is the rise over the run. So if I look at these numbers, I go -1, 0, 1, 2, 3, and then -6, -8, -10, -12, -14. What I want to do is I want to see the pattern. So this is my X, this is my Y. Run, this is the change in X, and this is the change in Y. It's not just X and Y, it's the change. What am I changing by each time? So if I look at the X's here, to go from -1 to 0, I had to add 1 there. To go from 0 to 1, I had to add 1. So it looks like each time here, I'm adding 1. So that's my change in X is 1. My change in Y, that looks like it's going down, right? Because if we think about that number line again, we have negative and we have positive. Well, I had -6, and then I went -8. That looks like I went more negative, right? I went from 6 to 8. So that means I'm subtracting 2. So each one of these, it looks like it's going down by 2 more. I'm getting more negative as I move along here. So that's my change in y, is negative 2. So we have negative 2 divided by 1. We don't have to leave that negative 2 divided by 1. We can just say negative 2 here. So that's my slope, negative 2. And then my y-intercept, what I want to do is I want to look for, if I'm thinking about a coordinate grid here, I want to know where it crosses this line. That's the y-axis. That's what we call the y-intercept. So that means that x should be 0. I didn't go right or I didn't go left. I'm right on top of the 0 line for x. I just went up or down for the y-intercept. So I want to go to my graph here and say, here's my 0 for x, so my y-intercept is negative 8. And now that I have an equation here, I'm going to go ahead and click on example just so you can see it. This is what we've been working on. We've been building up to this equation for quite a few weeks now. So we've been looking at this one. This is slope-intercept form. So y equals mx plus b. This should sound very familiar to us by now. The m is the slope. So that's the slope. That's the change we've been talking about. That's this change in x over the change in y. That's what this slope is, m. And it's always multiplied by the x. And then the b, that's our y-intercept, which is also our starting point. That's what we think of it as. And that's always what I talk about in class, is the y-intercept is your starting point. So in order to write an equation, we want to look at that, and I'm going to erase a little bit here. So we want y equals mx plus b. Well, m is my slope. We just found that. That's negative 2. And b, that's your y-intercept, which we identified as negative 8. So now I'm just going to fill the rest of this in. Y equals negative 2 times x. Do I have to put plus negative 8? No. I would just put minus 8 on there. So this is my equation. The y equals and x stay y equals and x, because those ones are ones that we manipulate to find specific coordinates later, but we don't actually change them when we write the equation. So they just stay just like this. Alrighty, next. Alright, we're going to do a line passes through the point negative 2, negative 9. So we have negative 2, negative 9. So here's an x and here's a y. This is going to be important in a second. And it has a slope, remember that's our m, negative 2. For whatever reason, m is the symbol for slope in this format. So now it says write an equation. Well, remember, in order to write an equation, I need the slope and the y-intercept, not just a random point. So what I do when they give me a point and they give me the slope is I'm going to use that equation, but I'm going to use it in a slightly different way. I'm going to fill in these three pieces I have. I have x, y, and m. And then I'm going to solve for b. That way I can go back in and plug in just m and b. So, because remember, x and y, this is a line. It could be this way. I'm just kind of guessing, but it's a line. It has a lot of points. And the points are x, y. That's the coordinate. That tells me how to get to that point. I go left 2 because it's negative 2, and I go down 9. So this is just a direction system. It tells me where to go to get to that point. So there's a ton of points on here. So that's why usually x and y stay x and y, because we can fill that in over and over again. But for this one, what we're going to do is we're just going to use this point. So y is negative 9. M is negative 5/2, because they told me that's my slope. And then x is negative 2. So I'm going to go times negative 2 plus b. So b is going to stay b right now, because I don't know what my y-intercept is. Not yet. I'm going to find it right now by doing this multiplication. I'm going to solve for b. So with this one, I have negative 2, and I'm dividing by 2. So what I can say is 2 divided by 2, well, that's 1. But there's a negative there, so it's going to be a negative 1. So I have negative 9, and then I have negative 5 times negative 1. It's a positive 5. 2 negatives multiplied together give you a positive, plus b. So now to get b all by itself, to figure out what b is, I'm just going to subtract 5 from this, like that. So I have negative 9 minus 5, and if we think of our number line again, we have negative 9, and we have negative 5. They're both negative. They're both going in the same direction. So I'm going to add them and keep the negative sign. So it's 14 negative equals 5 minus 5 cancels, and we get b. So now I have b and I have m. I can go back into my equation. Y equals mx plus b. Remember, x and y, they go back to x and y when you write this equation. You're writing a general equation for any point on the line. So all we want to fill in is m and b. We want it to say y equals the slope times x minus the y-intercept. These two are specific to this problem. So we had to do those other pieces to get here, but we want to make sure the y and the x go back for writing the general, because this one up here, this is very specific to this point, but it helps us figure out that missing piece. Alrighty. So we're going to find the equation of the line below. So remember, we always, always, always are looking for our y-intercept and our slope. Okay, those are our two things. Later, we're actually going to learn some other equations for this. But right now, those are what we need to write slope-intercept form. I need the slope and I need the intercept. Well, if I look right here, that doesn't really cross somewhere that looks easy for me to figure out. That might be 2.5, but I'm not sure. That'd be me guessing. You don't want to guess. We want to know for sure. So what we're going to do is we're going to figure out the slope, and we're going to use a point, just like we did in the last one. They're just not giving us the slope. They're not giving us the point. We have to choose. On here, we have 2 points to choose from. And the slope, no matter what, I'm going to do rise over run. So I can do this visually. I can go 1, 2, 3, 4, 5, 6, 7, 8. So I have to go down 8. Oh, that's a weird negative sign that I put there. I have to go down 8, and then I'd have to go 1, 2, 3, 4, 5, 6. So I'd have to go 6 to the right. So this is my slope. I want to reduce this. I don't want to leave it evens here because they can both divide by 2. So I'd have -4 thirds. I have to go down 4, and then I can go right 3. And if you notice, I land right on top of here if I do that. If I go down 4 again and I go right 3, there I go on the next point. So here's my slope. Now I need to choose one of these 2 points. It doesn't matter which one I choose. So I'm just going to go ahead and choose this one up here, and that's -1 and +4. X, Y. Alright, so now I'm going to use the y equals mx plus b. I don't know why I'm going to change my colors here. Mx plus b. So y is 4. M, we just found, is -4 thirds. And x is -1 plus b. So same thing we just did on the last screen. We just had to go through and find a few pieces first before we were able to plug it in here. So -4 thirds times -1. Well, that's just going to turn it into a, why did I do that? Go back. There we go. A +4 thirds. So now I'm going, this is a +4 thirds. I want to subtract 4 thirds from both sides like this. And then if I look at this, this is 4 minus 4 thirds. Well, I need this to be, I need it to have a 3 underneath. Right now it has a 1. All numbers have a 1 under it. So if I want to go from a 1 to a 3, that means I had to multiply by 3. I have to do the same thing on the top. So that means 4 times 3, which is 12. So this is just making it a like, giving it a like denominator. That's all that is. 12 minus 4, we get 8 thirds. This just comes across. You subtract across the top, but the bottom stays the same. So then I have 8 thirds equals b. So that's definitely not 2.5, but it is 2, but it's not going to be 2.5 because this would be 2 and let's see, 2 thirds, because I can take 6 out of here, which 3 and 3, that's the 2, and then there'd be 2 left over, so 2 thirds. So it's 2 and 2 thirds. It's a little bit more than 2.5. Not by much, but by enough. Okay. So, and we can, I don't think we want to write this as a mixed number we can leave it as 8/3, or you can write it as a decimal, but you'd have to round. And since it's not telling us to do any rounding, I would probably leave it as 8/3. All right, let's go back to this equation because we actually have to put it in the equation now. I have my y-intercept, I have my slope. So I have 4/3 and I have 8/3, and I'm going to put the rest of this in here, equals x plus 8/3. So it's not minus because it's not a negative 8/3. So now if we go down here and go y equals negative 4/3, whoops, what did I do that for? 4/3 x plus 8/3. Let's see what this guy does. Perfect. And it didn't give me any grief about that 8/3, even though it's an improper fraction. 2 and 2/3 would be more accurate, but it would also probably be okay with you using a decimal, but I'm not sure with the rounding. Be careful if it doesn't tell you to round on that rounding feature, because sometimes it'll mark you wrong on there because I don't even know what you'd round to since it didn't give you any instructions on it. Usually it'll say round to the nearest tenth, to the nearest hundredth, something along those lines if it wants you to do rounding. If it doesn't say that, I would just leave it the way it is. Okay, so now we have Manuel is a software salesman. His base salary is $2,300, and he makes an additional $50 for every copy of English is Fun he sells. Okay, so we have a salesperson, and he's selling books, it sounds like. Whenever we do a word problem, we want to go, what are we starting with? So we want to know our starting point. Remember, this is our y-intercept, which in our formula is our b. So our starting point here, no matter what, he's going to make $2,300, right? That's his starting salary, his base salary. So whether or not he sells a single book, he makes $2,300. And then the change, which is our slope, we represent as an m. That's what he gets for every copy he sells. So it's an additional amount that he gets. And you'll hear the word every or each or per. You'll hear some word that tells you that it's being multiplied. So it's going to be $50 per book, or for every book, however you want to write that. I'm changing it to per book so it's a little smaller here. So now we want to write an equation for this because they're asking us to write an equation down here. But we do need to pay attention to this next part. It says, let P represent his total pay and let N represent the number of copies of English is Fun he sells. Write an equation relating P to N. Then use this equation to find his total pay if he sells 21 copies of English is Fun. So we have two tasks. First, we have to write an equation relating P to N. Then we can use that equation to calculate what he gets paid if he sells 21 books. So this isn't one task, this is two different tasks. So the first task, we need to write an equation. So remember, we have a starting point and we have a change. It's going up by $50, but not just $50, $50 per book he sells. And remember, they told us to use N for the number of books that he sells. And they told us to use P for his total pay. Well, if I combine what his base salary with the additional amount he gets, that should be his total salary, right? So there we go. We just wrote an equation. We didn't use X and Y and M and B, I know, but it's actually the same idea. If I look at Y equals, and I'm going to go MX plus B like this. I'm just writing it out of order a little bit, but it's the same idea. Here's my slope. My X in this case is just N, and my Y-intercept is 23. My Y is P. We just switched a few variables around, but it's the same exact format we've been dealing with here. So it's just, for a word problem, a lot of the time we choose different letters to represent what's happening in the word problem. Makes it a little easier. So we have P equals 2,300 plus 50. And also be careful about the variables you use. Not only do they have to be in the correct order, so you don't want to switch their place here, but if it gives you a capital P and a capital N, use capitals. Don't use lowercase. That's a big no-no. We don't want to switch those around. All right, now we're going to use this equation to figure out how much he'll get paid if he sells 21 books. Well, if we know that the number of books is 21, we're just going to replace that, just like that. Now I have 50 plus 2,300 and that's going to equal his total pay. So we have $2,300 plus we need to do 50 times 21. And sometimes, I'm not paying attention, they didn't give us calculating this one, so they want us to calculate this one separately. So you could do it 5 times 21 and then add a 0 onto the end if that makes it a little easier. Because 5 times 21, that'd be 105. And then I can put the 0 back, so it'd be 1,050. So sometimes that's a little easier to ignore the 0. You could also write it off the side. We do have calculators also if you need them. So we can add these two back together. And let's see, we get 0, we get 5, 3, and 2. So if he sells 21 books, he gets $2,350. I believe they're going to want a comma here. Which part of the multiplication did I do wrong? Let's see. Oh, darn it. I forgot to add 1 and 2. It should be 3,000. Silly me. For some reason, I forgot to do that part. So, oops. Do we all make mistakes? Of course we do. We just need to go back and look. And that made sense. It wouldn't be 2,350 if he's already making 2,300. That means he only got an extra 50 bucks. He only sold 1 book. Nope, he sold 21 books. So, I just want to make sure. Logically, I should have looked at that and went, uh-oh. It happens. All right. So, we're going to go to the next piece here. Car rental company standard charge includes an initial fee plus an additional fee for each mile driven. The standard charge S in dollars is given by the function S equals 0.6M plus 18 and 95 cents, where M is the number of miles driven. The company also offers an option to insure the car against damage. The insurance charge I in dollars is given by the function I equals 0.15M plus 3.70. So we're going to let C be the total charge for the rental that includes insurance. Write an equation relating C to M. Identify your answer as much as possible. Sorry, simplify your answer as much as possible. I think I said identify. I'm being silly. So we have the standard charge and we have the insurance, right? We want to add both of those together to get the C, the total charge. So we know S is 60 cents per mile. That's what this 60M is. Since M is the number of miles, that tells me it's 60 cents per mile. I know they didn't tell us that, but that's what it is showing us in the equation. And then it's $18.95. That means there's a base fee there. No matter what, I'm going to pay $18.95 just to rent the car. So it's plus $18.95. And then I'm going to change this to blue just so we can see the difference here. And then I want to add the insurance. So the insurance is an additional 15 cents per mile. And it has another base fee on it. Just to choose the insurance is another $3.70. So we have 2 base fees and we have 2 mileage fees. We just need to combine these guys together to get our C, our total. So we have 60 cents per mile, 15 cents per mile. So that's 75 cents per mile. And then plus we have $18.95. And we're going to add $3.70 so that we can see what the base fee for both of these would be. And that would be $22.65 if you were to add these two together. You get 5, you get 16, carry this over, you get 8, 9, 10, 11, plus the carryover is 12, and then 1 plus 1 is 2. So this is the equation they're actually looking for. And when they say simplify as much as possible, what they mean is don't leave it like this up here. This isn't simplified. I had like terms to add. So that's all they mean when they want us to simplify it as much as possible, is just get it down to the smallest numbers you can. So it's super simple. So we could use either equation if we wanted to calculate just the base fee, or if we wanted to do just the insurance You're probably not going to get just the insurance without renting the car, so that's probably not going to happen, but you might get both of them. All right, we have one more of these guys. All right, let's expand that out again just so I can see it here. Suppose that the height in centimeters of a candle is a linear function of the amount of time in hours it has been burning. So if we think about that, the height of the candle is a linear function, meaning there's some kind of pattern, some kind of direction to it, of the amount of time it's been burning. Well, that makes sense. If you burn a candle, the height is going to go down. This line is going down. And it should burn at the same rate. It shouldn't burn faster or slower as time goes on. It should pretty much burn at the same rate. So it should be going down in a nice straight line as far as the height goes. After 6 hours of burning, a candle has a height of 22.6 centimeters. After 25 hours of burning, it has a height of 15 centimeters. What is the height of the candle after 12 hours? Well, we need to know at what rate it's burning here, right? So if we have centimeters, and then we also have, let's see, so this will be my Y, because that's the height. We can see the Y is height. And then my X is going to be the amount of time burning. So this was after 6 hours, this is the height. And after 25 hours, it was 15 centimeters. So we have X and we have Y. What we need to know is rise over run. I need to know at what rate is it going down? How fast is this candle shrinking? So if I'm looking at this, I'm going to go, how do I get from 22.6 to 15? So I can just simply go 22.6 minus 15, and they do have the calculator open here. So I just saw that. 22.6 minus 15, and you get 7.6. That's your rise. So this is my rise. Technically I'm falling, but we still call it a rise. Anytime you're moving up and down. So the Y is our vertical line. That's our rise, either up or down. So I'm dropping 7.6. And then for this one, I want to know how many hours have passed. So 6 minus 25. 6 minus 25. And I'm doing this a little backwards. I should be doing 25 minus 6 because not negative 19 hours have passed. 19 hours have passed. So I did that a little backwards in the calculator there. Because I also got a positive 7.6 here because I did it from top to bottom. But if I had done it the correct way, 0.2 from 0.1, then I would have gotten the negative like I was supposed to. So I have negative 7.6 over 19. And we can reduce this. Oop, I have to put the negative in first. I forgot about this calculator. If you use a smart calculator like the one on your phones and stuff, you usually type the number in first, and then you hit the little swap button that's usually plus minus, and it'll put the negative on there. If you're using the calculator in here, you hit the negative sign first, and then type the number. So we're going to divide by 19, and there we go. So we have negative 0.4. So it's going down at a rate of negative 0.4, which is, what it means is it's going down 0.4 centimeters, so 4/10 of a centimeter every minute. Sorry, every hour. These were hours, not minutes. I'm just losing my mind here. So every hour it's going down 4/10 of a centimeter. So now we want to know what's the height of the candle after 12 hours. So what I want to do is say 12 times the 0.4 so that I know this is how much more it's lost. It's lost another 4.8 centimeters. It was 15. So I need to kind of think that through and go, okay, it was 15. In 12 hours, it's lost 4.8. Right? Actually, I'm even fibbing to you a little more. We don't know the beginning point. The beginning point isn't 15. So let's back up just a second, because Negative 4.8 is the total amount it's lost over the last 12 hours, but it's already been burning for a certain number of time, right? So what we want to do is do a difference between, let's say, 6 to 12 hours. So we'll go 6, 12. So this is 6 hours, right? There's a 6-hour difference here. So in 6 hours, how much more has it fallen? So let's do that. 0.4 times 6. So it's gone down 2.4 centimeters from the 6-hour mark to the 12-hour mark. And at the 6-hour mark, it was 22.6 centimeters tall. So we can just subtract 22.6 minus 2.4, and this means that it's 20.2 centimeters tall at the 12-hour mark. So it's a little bit of kind of manipulating going around. We have to think about that. How do I know where to start? And I can go back to that 6-hour mark and say, okay, well, how many more hours have I burned from 6 to 12 hours? 6 hours there, right? 6 plus 6 is 12. And if I know every single hour goes down 0.4, I can just go from my 6-hour mark and subtract the 2.4 that is burned in those 6 hours. So that's definitely a little bit more involved as far as kind of thinking through it. That one's maybe not as obvious. All right, so that was section 2, and I will see you in section 3.